Hello, in this lesson, I'm going to go over special right triangles. Um, this is chapter A of the lessons in class. So in this, so we talk about two special right triangles we talk about here. One is a 45, 45, 90 right triangle, the other 30, 60, 90 right triangle. Note that this is a special triangle here is a isosceles right triangle. Two angles congruent, the sides also congruent. So in the first question, let's really review what those triangles are. I'm going to label the special triangle and draw the corresponding length and angles. So let me do that one here. So let's say, so if I have a right triangle, I'm just going to draw it. Okay, and okay, so that's my right triangle here. So if these two sides are congruent, then it's a 45, 45. So this one is 45 degree here, and this is 45 degree here. Now, we say for 45, 45, 90 triangle, we say the side length are the same. We could label them x with the length x. This is x, length x. You could use the Pythagorean theorem to show that the hypotenuse here is x square root 2. But here I'm just going to tell you. Yeah. Now, the other triangles are 30, 60, and 90. So this one looks like this. Okay. Oh, let me draw a little better. My overlapping here. So 30, 60, 90, and here. Almost straight lines, not too straight. Let me make it a little better. Okay, I'm just going to strip. Very good. So this is the 90. That is my 30. And that is my 60. Well, we'll say in a 30, 60, 90 triangle, the shortest side is the side that crosses from a 30-degree angle. Notice that this is the smallest angle, so therefore this must be the shortest side. So this side is my x. Okay, we said the other leg is x squared root 3. The hypotenuse is 2x. Okay, so that is all the size of the triangle and with the corresponding length ratio. So now let's use those special length to find the sum true function for the angles, sine, cosine, and tangent, the six true functions. The three of them here. So for each. So I want exact value here. Exact value means you don't need to take out your calculator. Okay, I want exact. So let's think about it. Let's do sine 30 first. So when I say sine 30, that means you are standing at here. If I'm here, my opposite will be here. This is the opposite side. That means this is the adjacent side, and that will be my hypotenuse. So we say to remember the six true function, which often in class we say Sohcahtoa. So Sohcahtoa means sine is equal to opposite over hypotenuse, ka, cosine adjacent over hypotenuse, toa tangent, toa opposite over adjacent. Now these three functions here is relative which point are you at, right? Right now I'm at 30, so my opposite is the x, my adjacent is the a, and hypotenuse 2x. So let's write it. So I have sine 30 is equal to opposite over hypotenuse, O over h. So O is this, O and h. And which is give me is the x over 2x, which is simplified, give me 1/2. Okay, that's the first one. Now cosine 30 is adjacent over hypotenuse. Again, I am standing over here at the start here. So my adjacent is x squared root 3. My hypotenuse is 2x. So that is squared x simplified over x is 1. So it's squared 3 over 2. And my tangent 30 is TOA, is opposite over adjacent. The opposite here is x. The adjacent is x squared root 3. So x over x is 1, so 1 over square root 3. Now notice the denominator here is a rational number. We usually like to rationalize denominator. So can we rationalize it? Type by times top and bottom by square root 3. So that's square root 3 over 3. So I found the 30-degree measurement for sine, cosine, and tangent. Now, let's look at 45. Okay. At 45, again, let's think about where we're standing. At 45 degree, that means I am over here. But doesn't really, since both legs are the same, so you could just change where you're at. So this is my opposite. That's my adjacent. Opposite to 45. Again, this is the opposite. And that's my hypotenuse. So sine 45. Again, opposite over adjacent, same thing. That is opposite is my x, my adjacent is also x. Oh, adjacent, the opposite of a hypotenuse, not adjacent. Let me erase it. Oh, my computer is getting slow. So opposite is x. My hypotenuse, sine opposite over hypotenuse, x squared root 2. And that is x over x is 1, so 1 over square root 2. Now I rationalize the denominator by times square root 2 to a special 1 here. Square root 2 over 2 is a 1, so I can multiply that. So that gives me square root 2 over 2. Okay, now cosine 40. Cosine 40, same thing, adjacent over hypotenuse, seems that it's still x over x squared root 2. So it's the same ratio as my sine. So this is x over x squared root 2, and that's the same thing as square root 2, same as the other one. And now let's do tangent. Tangent is TOA, opposite over adjacent. Okay, opposite over adjacent, where the both legs are equal length, thus x over x, which is give me a 1. Okay, and we just found the tangent the ratio for the 45 degree. Okay, now I'm gonna erase that one here. Now let's do 60. Well, before the 60 here, let's look at what we have here. So remember we labeled the sine, cos, opposite, adjacent, and hypotenuse. Well, your opposite is very relative to which angle you're at, right? Before we at angle 30, then my opposite is x, straight across. But when I change my location, now I am not at 30 anymore. I am at 60. So that means my opposite is going to change. So I am right here now. Okay. So my opposite is here. This is my opposite, and that will become my adjacent. Okay, so the common mistake students see is they still think always opposite have to be from 30. That's not the case. Okay, opposite is depending where you're standing, your opposite will be different, and your adjacent also different here. So let's write it again. Sine is opposite over adjacent. So my opposite over here is x squared over 3. Opposite over hypotenuse, I mean 2x. So it's x over x is 1, so square 3 over 2. Cosine 60 is adjacent over hypotenuse, which is x over 2x. Again, x over, simplify out, so 1/2. Now tangent 60 is opposite over adjacent, TOA. So that is opposite is my x squared root 3, adjacent is x, so just square root 3. And we found the 3-trig ratio in the exact answer, okay, for the function here. So those are the functions for trig ratio. Now let's kind of do one more question involving trig first. Again, application question. This one here, this is the one common missed question in this set of classworks. So in this one, it said for each measure below, find the nearest units. So let's look at what we have here. We have two triangles. We have the side length here, x and y. So notice that this is a 43, this is a 90-degree angle. So whatever 90 right angle triangle, we could do Pythagorean theorem, we could do all 6 trig functions and all that. So let's look at first x. I need to solve for x, okay? Well, I locate the right triangle, the triangle involving x. You're not sure, you can always redraw it. So I have this, okay? This is 90, and we are given this is 12.6. This is 43 degree, and that's my x. Well, ask yourself, which trig function involving these 3 measurements here? So we said 30 straight across is my opposite, so this is my opposite. I mean, this is my adjacent. And well, which trig function involving opposite and adjacent? Well, that is tangent. So I say for this one here, I could say tangent of 43 degree is equal to opposite over adjacent. Let me write a little better. Okay, opposite is 12.6. My adjacent here is x. Now, your goal is just to solve for x. I still love solving mistake here, so I'm going to show you how to do it exactly. So, to do one way to do it, you can add a 1 to the bottom to do cross multiply. If that's easier for you, I think that's easy for most. You could do it this way as well. So, I could say, well, I can cross multiply. If I cross multiply, I would have x times tangent 43 degree is equal to 12.6 times 1. 12.6 times is 12.6. Again, think about what you want. I want to isolate x. That means let's make x by itself on one side. Next, I can divide both sides by tangent 43 degree. Tangent 43 degree. Oh. So now I say, well, x, next part solve. So from here, the tangent 43 over tangent 43 is just 1. So I have x is equal to 12.6 over tangent 43 degree here. This part here, you can just substitute it into, plug in your calculator, and make sure your calculator is in degree mode because we have 43 degree. So this is approximately 13.5. Okay, so that's my x. Now, solve for y is very similar. Again, when you want to write equation involving y, we identify that this is a right triangle over here, which should function involving 12.6, 36, and y. Again, notice that if I am at 36, I'm right here, right? So my opposite is right here, and that is my adjacent. Again, opposite adjacent is tangent function. So therefore, tangent function is going to involving this y and this length here. So I say tangent of 36 degree, opposite over adjacent, that is 12.6 over y. In the same manner, you could solve like you solved for the previous one. Let's say I could add a 1 on the bottom, do cross multiply. And once you've done all that, divide both sides by tangent 36, you will get y. Oh, let me do it. Okay. It's the same one as previous one. So, right. So y is equal to 12.6 divided by tangent 36, which is same as similar way. So 12.6 divided by tangent 36 degree, and you can use that in your calculator, approximately 17.3. Okay, so that's how you do it. Now, area of a triangle. Okay, and so how will you find area of a triangle again? Think about it. Area triangle is half of base times height, and I'm going to write the formula down. Area is equal to half base of the triangle times the height. Okay, well, we can just plug it in. We know the base is just x plus y. So I have half of x plus y is my base, so x plus y, the length of the base. My height here is given is just my 12.6, so height. I'm going to write down first. So now, substitute again, so 1/2, my x and y we already found in previous one, 13.5 plus 17.3, and then times my height, in this case here, is just 12.6. So multiply it out, and you would get approximately 194.04. So area of the triangle is 194.04, approximately 94. I will say unit square. Unit square, so that will be my area. So, and that part concludes our lesson about special right triangles. And so let me zoom in again so you see the whole thing. So this is solving using tangent function, and here's a special right triangle. Okay, thank you for watching the video. I'll see you next time.